Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Today's kit is a fun one, and while I just assemble a few items we're going to need, let me jump in to tell you that it is a computer related kit. And I'm going to need, and you're going to need, something similar in that you're going to need a cassette tape player that has record and play, a audio tape, and look, this is a brand new Maxell tape. Ooh, and we'll have a little bit of an unwrapping of that later. You will need the Mitch Electronics Datacorder kit, and you can look there for the details. There you go. Go get one. And I've printed out from their instruction manual the component identification thing, because the one thing that Mitch Electronics don't do is put the values on their silk screen. They only put the component numbers, which, yeah, you know, I'm not a massive fan of that. For obvious reasons. It means I have to go and hunt around for datasheet things, but that's fine. If you're at home doing it properly, you'll be following their instructions and figuring out how it all works, rather than just jumping in like me, soldering everything on and praying that it'll work at the end. So what it basically is, though, it's a set of components designed to take a serial output and turn it into sound, and then store that sound on an audio tape. I think it's a 300 baud I read this kit operates at, and then also you can take that sound and play it back. I mean, that's pretty much it. When you take the sound, play it back, you'll see the serial output on your terminal, so it's pretty groovy, to be honest with you. It's very much how all of the 8-bit computers we had back in day when I were a lad used to operate. So I'm just putting in the IC holders and some of the easy stuff, because normally we start with the hard stuff, don't we? The resistors and all of that stuff. It's like, no, let's just start with the easy stuff. Let's give ourselves a break, because it's a warm Saturday afternoon and I'm not looking for too much adventure right now. I just want it to go well, go smoothly. I'm going to try flipping this, and I found this bit of foam literally just sitting on the table, so that might work. Oh, that does work quite well. And I'll just leave it there. Oh no, some stuff is trying to squeeze through. But don't worry, we're going to zoom in. We're going to get in there. We're going to attack it. There we go. I'm just going to get me solder ready. I like how all my components I've scattered on the table are just in the path of the solder. So when we pull that tight, it's going to drop all those on the floor. Really going to try to get some pressure on this piece, because that is one of those components that is trying to escape. So I'm going to push down on that on the foam, press the foam, get at least one leg on that done. So that's staying put. And I'll do the opposite leg. So if you're doing, it's like putting the head bolts on an engine. You always go the opposite corners and then work your way around, so you don't accidentally trap in, stresses and strains into the devices that are unintended, because they don't like that. Basically, they don't like it, and they might fall out. So let's pop that in as well. That's good there. And one more. And then we're ready to actually do the main soldering. So that's basically like a tack solder, I call it. A bit like tack welding, if you ever did welding, where you just have a little bit on there just to get everything kind of in place. Oh gosh, I forgot those two totally. But you can see they're all in place. They're not electrically connected, but they're just ready to be soldered. They're all sitting kind of right. Let's just get these two in first. I hear a lot of clattering. A lot of clattering in the old kitchen, and it's because, being a rather nice day, it was the first barbecue of the season, and we could have had the first barbecue of the season ages ago. To be honest, the longest day I think is next Friday, so it means we're actually on our way back to winter. But I hadn't attacked the barbecue, so it was still dirty, full of bacteria and mushrooms and all those sorts of things that like to grow in it when you leave it through the winter. But we're there now, and I'm sure we're going to nuke a few more bits of animal and veg in there. Right, we're ready to go now. If you are a fan of the flux, I'm going to put a bit of flux on there for you, because some people do complain, I don't really use it that much on a new thing, but you can. It's just plain to clean, really. And the flux I use, of course, is a thick gel flux. It's the only flux worth getting, to be honest with you. I've got litres of liquid flux that I just choose to ignore because it's terrible. The old gel flux, though, you can't go wrong with it. Get that in. What's my soldering iron doing? I'm running it a lot colder these days because I know you guys like to see a cold flux, sorry, a cold solder without too much oxidization, but I'm kind of, it slows you down a lot, doesn't it? And you can see here it's taking time because it's got to heat that joint up. The joint's taking away the heat, the solder's taking away the heat. So I'm running it at 238 now, whereas before when you used to see these videos I was running it at like 380. It's just nuclear. But it does cost you tips that way, so if you do want to run your gear at those high temperatures, make sure you've got plenty of tips because they'll literally oxidize off if you leave the iron on too long. That's fine. You might have one of those fancy irons that knows when it's being used. And I did see a comment recently that did say blob of blue tack. Get a blob of blue tack to hold your PCB. Probably would have been a good idea. So I think the heart of this circuit, let's get back to this circuit. It looks like there's a couple of 555 timers. So they're going to be being used as an oscillator to make the tone. If I'm not mistaken, it will be basically when there's a 1, it will be sending a sort of square wave out, like a and then when there's a 0 in your data stream, it will be silence. So it's a pretty simple circuit. You probably could use the in and the out together if you wanted to. So let's have a look here. So we've got a whole mess of resistors here. So I tell you what, why don't I sort these out off camera? You don't need to watch me sorting out resistors. I'm basically looking at the colour on this chart and then putting them in a little pile. Sorting out the resistors bored me to tears, so I thought I'd just do the capacitors first. There's two different types of capacitor, just sort through them. You'll see them clearly indicated with two distinct markings, and there'll be 2 of one kind and a bunch of the other kind. And just put the 2 that are different in the oles. You can't beat them. You can't get them wrong. They're the 10 nanofarad capacitors, which I believe will be marked with a 103. So I've just bent the legs and I've just poked them through, and I've done the old splay leg technique on these guys because that kind of seems reasonably successful and stuff like that. It's just whatever works, really. Don't worry about it. Now there was a discussion in the Discord about what the different PCB layers and stuff was, and we were talking about solder resist. And solder resist is basically a varnish, because to be honest with you, I know it might not seem like it if you're soldering stuff and it's all going a bit wrong, that solder really, when you're brazing 2 pieces of metal together, it really wants everything to be clean and ready and fluxed and, you know, all sorts of things, all the things to be good basically for it to work. So solder doesn't really stick to things that it ought not to stick to. So the reason you've got that solder resist on the board is because it's like a varnish, and when you've got an IC with a couple of pins that are near each other, obviously they could accidentally jump onto each other and make a short circuit, but really it doesn't happen. Okay, so that solder resist just goes no. It's like the plague. It doesn't want to touch it. It doesn't want to stick to it. So that's why it's there. And if you've got board that doesn't have solder resist, normally it's okay as long as there's no ground planes, because it means you just got a bigger gap between stuff. But you can do it even with quite fine pitch surface mount. You don't necessarily need solder resist if you're making that board at home, for example. You can still get away with it. You just have to be a bit more careful. But there you go. But on a commercial board like this, you can see I'm not taking any care. It'll be fine. So I did pop in the little transistor, I think it was. What was that? Let's see. Yes, it was a 2N3904 transistor right there. So that's obviously doing the switching on the output to probably give you that digital. So remember, you've got 2 separate circuits here. One is this input circuit, which is going to be taking the sound and then literally switching it into a digital output on the TX pin here. One that's taking the RX, I don't know, these could be the other way around, right? I don't know. The RX and TX often on serial get mixed up running around. And then the other one, which is taking the signal from the PC, and when it sees it's high, it goes woo, and puts a woo. When it's a low, it just goes silent. So that's what that is. And these are just volume controls. That's just to attenuate the output. Because if you remember, that was quite sensitive on your equipment. Right, the old diode. That's definitely the correct way of pronouncing them, diodes. And you can see on your PCB a little picture of it. Make sure it matches up, and don't bend the legs like that where I've just sort of tried to splay them in. I'm going to use a leg bender. Whoa! It's trying to escape on me. Not this time. You're too slow today. What? That was really weird. I don't think I've ever had a component try to escape on me like that so vigorously. I mean, it really doesn't want to be part of this circuit, but it's going to be. And just as a quick aside, the board, the PCB is actually quite well made. It is a nice board. There is a standard, one of my friends was telling me that there is a standard for cassette tape digital interfaces in terms of how they chop up the data and get it on there. And I can't remember the name. He was quite sure of it, and he did tell me the name of it. But this doesn't have it. There's no intelligence on this board, so it's relying entirely on the microcontroller or computer that you connect this to provide any kind of intelligence. So if you have a missed block or something up with the data, you ain't getting that back, boy. But we could try getting an old cassette tape, you know, like a Commodore 64 one or something, and playing it just to see if it's any way near what we've got here. So I can't beat about the bush really. I will have to do my whole resistor pile now. So yeah, now is a good time to jump cut. I'm ready! So I've already soldered in the few little miscellaneous ones, because now we've got a big bunch of some that are all the same. So lessons learned. The PCB really likes the resistors to be bent like at a kind of 100% bend. Do you see what I mean? Bending them straight from the body. That means you don't need a fancy leg bender, but it also means if you do use a leg bender like I did, they're all going to be wrong and they're going to take a lot of force to get through. So what you could do though, if you're kind of patient, you could sit there like this and get them nicely flattened. Ah! Or do that. It's tricky though if you try. I'm going to just have to try to shove this one in now because it's so bent. If you don't bend them correctly, it can be a bit annoying really. There's a couple of different things. But you could try this. Try bending them too narrow on a PCB that needs a wide hole, has wide spaced holes, and try bending one too wide on a PCB that has narrow holes, and you'll see what I mean. I mean, in your soldering career, you're likely to come across a couple of those scenarios, but you can't really get it too wrong, can you? Let's put my sponge there. I have a magnet attached to that, and it's ever so annoying. Every now and then it's handy where you want to pick up a screw, but more often than not when you move that from somewhere, it'll have a little vice grips or pliers or screwdriver hanging off it, and that's what you heard rattling around there trying to shake off an unwanted passenger. We're almost there though, don't worry. Bear with me, we're almost there. Just R3 now and R4 to go, and that's pretty much the whole circuit. What I'm going to have to do though is we're really going to have to find a source for some serial data. And we ought to find a serial port because it just came with raw wires. So you've got different options. I mean, you could use, if you've got like an Arduino or a buoy board or something like that to produce a serial stream for you. There, it just can be reciting the works of Shakespeare or something. Or I think I've got a little EEPC setup that I use for the RetroNet. You could use this with a RetroNet actually and do Wi-Fi to cassette transfer, which is kind of mental really. I don't know why you'd want to do that, but you could. And if you're into top soldering, you could, I'll just show you this now, we might get away with it. Depending on the nature of the board, sometimes you can get away with soldering from the top like that, one of the legs. And I'm not going to get away with it, so I'm just going to flip it over and go the tedious leg by leg route. And just to show you what I'm doing when I do this, and I am going to go around and make sure everything's seated properly afterwards because I can tell they're not right now, is just hold the soldering iron to the side of the component, put a little bit of a blob, and then when it's ready you'll see the blob just drop down into that hole. There's not really too much beyond that. When you're applying your solder, apply it at the junction between the tip, I'll show you here, between the tip and the component lead, and that'll have a decent one. It should have a decent thermal sort of connection between the two, but what's more important really is that your solder will have flux in it, and you kind of want that flux to start to melt so that it will, you know, really facilitate that flow. And sometimes, you know, there isn't a great thermal connection between the two things, and that's what really bridges it. The flux in the solder will bridge that and get that heat transferring nicely. I'm just very hot. I'm just trying to push through a component that's clearly not seated right, but for some reason, here we go, tenaciously in not wanting to go down, not wanting to cooperate with me, and that's just not on. That's not what we're here for. Oh no. There we go. So once you've made sure they're all sitting as flush as you desire, just go do the other legs and then chop them off. Chop off the spares. So let's try this guy again. Put it in the junction. Plop. In it goes. Turn it round again. In the junction. Come on. It's not plopping. There you go. It plopped. It plopped. It's quite a thick PCB too. Lots of ground plane. Bang. I guess it is an audio board though, so it probably does need that ground plane to reduce. That's the last one. We're in. Now let's just get those component leads off. Don't need that little forest there. I wonder what will happen when we power this up, if it will just sort of start howling right away, you know. Ooh, ooh. I didn't read the instructions. I suspect you're going to need like 5 volts, but what I wonder is if it's better to use a power supply or batteries. I'd say it's probably better to use batteries. The reason being there'll be less noise on batteries. There should be no noise on batteries because it would just be a clean DC source. Right, IC1, IC2, IC3. So let's have a look at our little sheet here. That's what I'm looking at. See where our ICs are at the top. We've got 2 555 timers. That's IC1 and IC2. So that's a 555, and that's a Texas Instruments 555, and that's an LM358, which is going to be some sort of op-amp or something. Right, IC1, IC2. So just make sure they're the right way around, and you'll see that because there's a little divot there. If you've put the holder in the right way around, assuming. But look at the PCB. You can see right even under the PCB there's this little silk screen showing that little cutaway. So that's IC1 in here. IC1, hold tight. And IC2. Oh, these are so nice, these little 8-pin dips. They just drop straight in. There's hardly any splaying to control. Wow. Wow, wait, mother, look at that. Get your red and your white wires on. Let's just see. I'm just having a look around my bench here to see. I actually do have this from something I was making earlier. I'm just going to take the power. Oh my gosh! Right, time to turn up that soldering iron. I can't run on it. I can't have it running on fumes anymore. It's not like we're doing some tiny little surface mount stuff. This is real stuff here. Come on. That's it. That's it. There we go. So I'm just checking the polarity of these. The one with the white stripe is positive on my circuit. Okay, and we're going to get the white stripe on the VCC. And we're going to get the other one on the ground. And these are really quite crusty wires, but when you're doing this, you can make sure that it's nice. So before I do anything, I'm going to just turn on the bench power supply, turn it off 12 volts down to sort of 5. And I've got my pot noodle speaker here. I just want to see if we get anything right now. So there we go. We should be able to get something. If we plug this in on the out, I'm going to turn this on. Woohoo! There you go. So we should be able to manipulate this by, oh, I've got a resistor here. I'm going to put it between the TX and there. If I put it between TX and ground, it's quiet. There you go. That's kind of how it works. So that seems to work. We can't test the other way right now. But effectively you could test the other way, couldn't you? Because you could plug that back in on itself, but we're not going to do that right now. What we're going to do is find out how to connect this up to the serial of my little mini laptop. Welcome back. You can see that I've got it set up now. I wasted a lot of time connecting this to a regular, this to a regular serial port before realizing it doesn't actually operate at serial. It doesn't have a serial level or at least an RS-232 input and output voltage level. So what I've had to do is get a booby board, and I've disabled the onboard microcontroller. So I'm just using its FTDI232 chip as a USB to serial chip, because that does the level translation and stuff in it. Well, you kind of don't need it because it's already at sort of TTL level. And I've actually got it putting output on the screen, which I'll show you in a moment. So I had to tune these up, and it's kind of tuned up to get something that's kind of right, and it's still not great, but I'll just plug it into the speaker so you can hear what it sounds like. Ready? Doesn't that sound very much like the tapes of yesteryear? So I'll show you what I've got here. I've got it going from its output back to its input. And we'll move this across. I'm going to turn this screen. Now, you will forgive me, it's just a little netbook. And you'll be able to see on the screen, it's actually displaying the README file in Realterm's own folder. It's a 300 board, and it is messing up some stuff here, but you can just about see that it is, is real data there. So what I've been doing is I've been leaving it on the desk here while I've been sort of monitoring it and trying to adjust these two pots. So just to show you, this one is the output volume level from here, and this one is the sort of input attenuation, I'd say, is the best way to describe it. So the reason you've got two levels, of course, is that when you've got a tape, you've probably got no control of what the tape player is putting out. So this is just a little bit of extra on there. So what I will try to do, I will get the cassette tape ready. So I know it's messed up. We're seeing it messed up. But if we can get something that's at least close to what we're getting on the loop back, I'd say it kind of works. And then all the rest is tuning. So we can figure out how to tune all of that in the future. So I'm just going to plug my tape player AC adapter in. We'll just check that. This was the one I got in Asda, by the way. Yep, still works good. And this is a brand new old stock tape. It's not every day you get to open an audio tape, to be honest with you, so I'm savouring this a little bit. I did buy 10 of these in 2 packs of 5, so I didn't show you the 5-pack unwrapping, but you get to see the individual tape. Woohoo! So cool. Is there a date on this? No. I mean, does it? Smells tapey. It's even got the little doodad in it. Fantastic. Okay, so I'm going to pop that in the old tape player. I can't remember really which way tapes go. Is that right? Yep, that's correct. So I'm going to rewind the tape. And then I'm going to plug into the record in on the tape the output. So I'm going to plug that in like so. External mic. Now we're going to have problems with levels, of course, because there is a chance it's all going to be messed up. So I'm going to push record and play. Oh, you can hear it. Hang on, I think I can hear a noise. I don't know if that's the output from there. If I play the volume, yeah, definitely. You can kind of hear a quiet version of what's going on. I'll give it a few more seconds. Right, that's all good. Let's rewind that. Serenade me with your sounds. Okay, and then we're going to plug this in the phone's output and then put that into the input here. And then I'm going to hit play while we witness what's going to happen here on this screeny bob. Could put the font up, couldn't I? I'm pushing play now. Oh! Well, actually, the hex font file is in the real term directory, and now there's a bunch of junk. You ignore this section. To use this, you need I/O drivers, Win9x. There is, of course, something. I'm assuming what I'm sending is a plain text file, but it says say readme.txt. But wow, that kind of worked, didn't it? That kind of worked. I'm pretty impressed with all of this. In fact, I say impressed, I'm a little bit distressed in how low a quality it is in terms of that. But wow, there's room for tuning here, right, guys? You've got the adapter here working. You've got your booby board doing the level translation and serial port emulation. You've got real term set to 300 board actually talking. You had it working in loop through, and you had the same, I think, the same level of quality recording to an audio tape and back from an audio tape. So I think in terms of a kit, it's definitely demonstrative of what's going on, but it's probably a little bit too simplistic. I think if you probably wanted a more pro kit, you'd have to have all sorts of automatic gain controls and maybe a little micro on here, so it could actually just packetize the data and put in some Hamming codes or something, so at least it could error correct. But we'll play with this a little bit more. Again, that's the Mitch Electronics 63 kit. Stay tuned maybe in a future video while I keep working on this and we'll get it to do something pretty more reliable. If you've already got this kit though, please feel free to ping me and contact me in the Discord, and we can see, of course, your results and compare them to my own and maybe make the appropriate adjustments. Just wondering, does this have a carrying handle? Oh, it has a carrying handle on this tape player. How retro. Yeah, let's see if we can get this doing something reliably. So yeah, ping me, hit that bell icon if you want to be notified when that video's out. Like, share, subscribe, and as ever, thanks for watching.